Hi everyone, this is Mrs. Snowbeck. Today we are going to cover Unit 8, Lesson 2. And before we get started, let's do a quick review of the formulas from 8.1. Take a minute, see if you can remember in your brain, what's the formula for area of a parallelogram? If you thought base times height, you are correct. How about the formula for area of a triangle? If you thought base times height divide by 2, you are correct. Today we're going to learn a few formulas. The first is for area of a trapezoid. Remember, a trapezoid is a quadrilateral with one pair of parallel sides. And so to find the area of this, the formula goes area equals height times base 1 plus base 2 divided by 2. So let's label our picture. Remember the two sides that are parallel, those are your bases. So call one of them base 1, one of them base 2. It doesn't matter which one's which. But the height has to be perpendicular to those bases, so it has to be perpendicular to both. That dotted line there would be the height of the trapezoid. Number 1. One of Ella's isosceles trapezoid-shaped handbags is shown. Find the amount of material used to make the side shown. So we pretty much want to find the area of a trapezoid, one side of this purse. I think we know base 1 and base 2, but we do not know the height. The 30 is this slanted side over here, which is not the height of the trapezoid. So we're going to have to find that height. So drop down another dotted line. The distance from those between the dotted lines is going to be 28, but the distance of the whole bottom of the purse is 58. So if we do 58 minus 28, there's 30 left. Half of it has to go on each side. So 30 divided by 2 is 15, which means this side is 15 and this side is 15. You can now find the height. You could do a couple of different things, but probably the thing that's most familiar to you is Pythagorean theorem. So you could do 15 squared plus h squared equals 30 squared. So again, let me just outline that triangle. I'm over here on the left side of the handbag in this pink triangle doing Pythagorean theorem to find the height. So 15 squared is 225, h squared, can't do much with that yet, and 30 squared is 900. Subtract your 225. H squared equals 675. And then, of course, you have to take the square root. And the height turns out to be 25.98. So I'll just write that on here, 25.98. I think we now have all of the numbers we need to find the area, so let's plug them into our formula. So I've written the formula here for area of a trapezoid. We know it's a trapezoid because it tells us in the problem. So the height we just solved for, it was 25.98. The bases are 28 and 58, and then divide by 2. So type that into your calculator. Practice actually typing it in. Do the parentheses first, then multiply by 25.98, hit equals, and then divide by 2. If you're typing it in the correct way, you should get 1117.17. And when you label area, remember it's units squared, so centimeters squared. Number 2, find the area of one side of the steel used to make this razor blade shown. So again, it looks like I have base 1, I have base 2, but we do not have the height. We need that height. This time, I think what we could do is use a little SOHCAHTOA because they give us one of the angles there. So if you think about that 68-degree angle, I think the 1 is the hypotenuse on this triangle over here, and the h is opposite. So think about SOHCAHTOA and pick one of those. And I think we need the one with the O and the H, so I would pick SO. So I would go sine of 68 equals opposite over hypotenuse, so h over 1. Multiply both sides by 1. type it in your calculator. Really, you just have to type in sine 68. And I think it turns out to be 0.93. So 0.93 is going to be the height of the razor blade. All right, I believe this is a trapezoid, so we're going to do the trapezoid formula, which is height times base 1 plus base 2, divide by 2. So our height, that's what we just figured out. It's 0.93. Our bases are 2 and 1.25, so we add those together and divide by 2. Please practice typing it in. And I got approximately 1.5, and remember it's inches squared. Number 3, Kevin designed a deck shaped like the trapezoid shown below. Find the area of the deck. Well, I think this would be base 1 and this would be base 2. So we know one of the bases, and I think the 4 is the height. These to me look like they're 90-degree corners. They probably should have been filled in. But we need to find base 1. And so what I did is I dropped down a dotted line from the base to base, and I knew this height would be 4. And I used, let me get a little highlighter over here. I used this blue triangle over here, and I figured out the length down here. I'll call it X. And once I know what that is, I can subtract from 9 to figure out the other part. And the top base would be the same as that. So we're going to start with this triangle over here on the right, and we're going to do 4 squared plus x squared equals 5 squared. So we have 16 plus x squared equals 25. Of course, minus your 16, and you get x squared equals 9. Take the square root, x equals 3. All right, so I'm just going to do a little erasing here. This over here now is 3, so 9 take away 3 means this part has to be 6. And if that part is 6, then the part up at the top is also going to be 6. So now we know our base 1, and we know our base 2, and we know our height. So for a trapezoid, which it tells us it is a trapezoid, we're going to do height times base 1 plus base 2, divide by 2. The height was 4. The bases are 6 and 9, and then divide by 2. Go ahead and type it in. If you do it correctly, it should be 30, and the label would be feet squared. Please pause the video and try number 3 on your own. I'll work through it quickly here. What I did is I dropped down. I needed to find this height. So I dropped both of those heights down. I knew the distance between them was 2. 4 minus 2 is 2. So that left, I had to take those 2 extras and divide it by 2, which was 1. So each of these little spots was 1 is what I figured out. Then I used this triangle, and this would be a right angle, so you can do 1 squared plus h squared equals 3 squared. So it's 1 plus h squared equals 9. Subtract your 1. H squared equals 8. And I just changed it to a decimal. I had h is approximately 2.83. So now we have all of our things. It's going to go area equals height, which is 2.83. times base 1 plus base 2, which are 2 and 4, and then divide by 2. And the area for one earring turned out to be 8.49 centimeters squared. Now we're going to find the area for a rhombus and a kite. So let's remind ourselves, what is a rhombus? A rhombus is a quadrilateral that has 4 congruent sides. All 4 sides are equal, but unlike a square, the corners are not all 90 degrees. So kite, what is a kite? Well, a kite is a quadrilateral that has 2 pairs of consecutive congruent sides. And so let's just label those. This is a rhombus. This is a kite. And the formula for them is actually the same. The formula goes like this. Area equals diagonal 1 times diagonal 2 divide by 2. And remember what diagonals are. Diagonals go across from one corner to the opposite corner. So here's diagonal 1 and here's diagonal 2. Here's diagonal 1, here's diagonal 2. And it really doesn't matter which one you call 1 or 2. Number 5, this one's pretty basic. Find the area of the kite. You can see up here is 8, so down here, this distance across would be 8. That's one of the diagonals. And then this distance here is 15, so this would also be 15. So remember your formula, diagonal 1 times diagonal 2 divide by 2. So this one's just 8 times 15 divide by 2. Area ends up being 60 meters squared. Let's try number 6. So this one's slightly different. To get the whole diagonal, I see one side of this diagonal is 10, so this is also 10. So then that whole diagonal, I'll call it diagonal 1, would be 20. And then on the other diagonal, I see one side is 12, so the other side must be 12. 12 plus 12 is 24. So our diagonals have to you have to double the lengths given to get the diagonals. So again, our formula is right over here. Diagonal 1, so 20 times 24, divide by 2. Ends up being 240, and it's feet squared. I like this one. It says find the value of x given the area of the kite is 92. So some keywords here, area, kite. My formula is diagonal 1 times diagonal 2 divide by 2. Let's plug in what we know. Well, we know the area. The area is 92, so that's going to go in for the A. I know one of the diagonals. If I look over here, the 22 is the same as this one. So one of the diagonals is 22, the other one is x, and then I have to divide by 2. Now just simplify. A quick thing you can do is you can just divide these, and so you can take 92 equals 11x, or you could have multiplied both sides by 2, doesn't really matter. Divide by 11 if you do it this way, and x should end up being 8.36, and this time it's just the length of the diagonal, so it's just inches. Last but not least, number 8, find the area of the rhombus if RT is 24, and the measure of angle RST is 54. Let's label that. So I see RT right here. That is 24. So one of our diagonals is 24. And then RST is this whole angle over here. That's 54. Now I'm going to take 54 and cut it in half. 54 cut in half is 27. So each side here is 27 and 27. This would be a right angle. Okay, the reason that's important is because I know one of the diagonals, but I don't know this diagonal. I need to find that. So what I'm going to actually do is just take part of my rhombus here. I'm outlining it in green, and I'm going to use that triangle and try to find this. Let me write that in a darker color. I'm going to try to find x, which is half of the diagonal from S to U. I know from R to T is 24, so from R to the center must be 24 divided by 2, or 12. All the way across is 24, so halfway across is 12. So here's what I end up with. I'm just going to redraw that triangle. I end up with, this is 12, this is 90. I want to find this side, and my angle here is 27. So that's that green triangle that you see in the picture. We can use SOHCAHTOA. So the 12 is opposite of the 27, and the x is adjacent to 27. So think about SOHCAHTOA and pick one of those. You want the one with the O and the A. So I think we want TOA. And we're going to say tangent 27 equals, and it's opposite over adjacent. All right, we're going to have to solve by multiplying by whatever's on the bottom of the fraction. So our x's will cancel out. And then remember, it's x times tangent 27, so you have to divide by tangent 27 on each side to solve it. These cancel, so x is going to be 12 divided by tangent 27. And that turns out to be 23.55. 23.55. Now, what we just found, this 23.55, is this distance from S to the middle of the rhombus. So to get our second diagonal, we're going to have to double that. We're going to have to multiply by 2. And so our second diagonal is going to be 47.10. All right, we've got our first diagonal, we've got our second diagonal. We can now find the area of the rhombus. It's diagonal 1 times diagonal 2 divided by 2. So it's going to be 24 times 47.10 divided by 2. Answer should be 565.2 units squared. Awesome, that wraps up unit 8.2. So will you please try the practice? If you have questions, let me know.